Alright guys, let's get started. So this is question 1. Our question asks, you pay $3 to roll a die. Whatever the six-sided die rolls is the amount of dollars you receive. For example, you could pay $3, roll on the die, and you would lose $1 as a result. Use the table to calculate the following. So on our first column here, these are our events. So in the case that we roll 1 on the die, that would be event 1. On the case that we roll 2 on the die, that would be event 2, and so on. Now on the second column here, we see an X, and this X represents the amount of money we're going to end up with after we roll the die. So let's look at the first row here. So on number 1, we would roll 1 on the die, and in the case that we rolled 1, we paid $3, but we ended up with $1, so that means we'd have a result of negative $2. In the case of event 2, we'd pay $3 but only end up with $2, so we would end up with losing $1. In the case that we paid $3 but we ended up with 3 again, well, nothing happened and we didn't gain or lose any money. In the case where we got 4 on the die but we paid the $3, we'd end up with a positive, gaining $1, I'm sorry, and so on. So this would be a gain of $2, and this would be a gain of $3. Now this P of X, this is the probability that we gain 1 on the dice, 2 on the dice, 3 on the dice, and so on, that we roll it. So the probability that we get 1 on a 6-sided dice, that would be a 1 out of 6 chance. And in the case that we got 2 on a 6-sided dice, there would still be 1 out of 6. Same for 3. Same for 4. Same for 5. And lastly, same for 6. So the chance that we get any of these numbers, when we roll the die once, it would always end up as 1 out of 6 chance. Now, when we look at this column here, it's asking us to multiply our X value by our P of X. So this would be a negative 2 out of 6, negative 1 out of 6, 0, 1 out of 6, 2 times 1 over 6 is 2 over 6, positive, and then this one, 3 times 1 out of 6 is 3 out of 6, or 1/2. Okay, let's finish filling out our table here. So this column is asking us to subtract this E of X represents our expected value, which is what question A is asking for. Calculate the expected value of your profit loss. And we know that the expected value is actually the mean, and it's a weighted average of the possible outcomes. And that would be the sum of our X times P of X values right here on column 4. So if we add up all of these guys, well, negative 2 over 6 would cancel out with the 2 over 6 here, or negative 1 over 6 plus 1 over 6 would cancel there. 0 has no effect on the sum, and we'd end up with 3 over 6. So again, our E of X, our expected value, is the weighted average, sorry, it's not typing. But anyways, it's the weighted average of the possible outcomes, or the sum of our column 4, excuse me. So our E of X is equal to 1/2. Okay, so right here on column 5, it's asking us to subtract our expected value, which we already got, from x and get this, and then square it. So doing that, we'd get 25 out of 4, 9 out of 4, 1 over 4, 1 over 4, 9 out of 4, and 25 out of 4. After that, we'd multiply this value by our p of x value, which is this guy. So we're gonna multiply this value times that guy right here. So let's go ahead and do that. For row 1, it would be 25 over 4. Row 2 would be 3 over 8. This would be 1 over 24. 1 over 24 again. 9 out of 24. And lastly, 25 out of 24. And there we go. Our whole table is filled out and ready to go. So we have our table filled out. We have our expected value, which again, we added up all the values in column 4. And now it's asking to calculate the variance of the profit loss. Well, in order to calculate the variance of the profit loss, all we have to do is add up all the values in our last column right here. And this would give us, sorry, I was calculating that. So our variance comes out to 35 over 12, or 2.917. So again, this variance here is the variability in the values of a random variable. And that's done by adding up all of these values here. And we ended up getting 2.917 when we added up all of these guys. So we're seeing a profit loss, which she kind of gives us a hint here. We're paying $3, but it seems that on average we're ending up with 2.917 if we were to play this game. The last question asks, is the expected value a quantity you could actually be paid when playing the game? Explain why the expected value is sometimes not observable value for the game. So we know when doing this that this is a value you typically get if you played an infinite amount of times. So you would have to play this many times to get this expected value. So it wouldn't be observable because you have to do this so many times to be accurate. So we have a general idea we could get, but like I said, in order to be really close to this number, you'd have to play this infinitely amount of times. So let's write down what I put on my exam and got all the points for it. It's the value you'd typically get if you played an infinite amount of times. So it could be. But it's not observable because you'd have to do an infinite amount of times. So let's do a run through of what we did today. We filled out our table by evaluating and coming up with our x values. We came up with the probability of getting each event. Then we ended up multiplying our x times our p of x value. Then we subtracted our expected value, which we ended up getting by adding up all the values in column 4. We ended up, subtracting our expected value from our x and squaring that. And that's how we got all of these guys. And then we multiplied these guys by our p of x value for our last column, which if you add it all up, you'd get the variance. And one more thing I wanted to add, if we wanted to get our standard deviation, we already have our variance, so all we do is get the square root of that guy. Just something I wanted to add. And that's our problem.